Welcome back to the deep dive. We're tackling a subject today that honestly suffers from what I would call a massive PR problem.
Oh, totally. A huge PR problem.
Right. Like when I mention geography to you, or really to anyone, I feel like most people instantly revert to like third grade.
Yeah, memorizing state capitals.
Exactly. Memorizing capitals, maybe coloring inside the lines of a blank map, or, just trying to remember if it's latitude or longitude that goes up and down.
Right. It's the classic dinner party conversation killer. You tell someone you studied geography, and they immediately ask you, like, what the capital of Kyrgyzstan is.
Which
And if you don't know it, they just assume you're terrible at geography.
Right. But looking at the stack of research and notes we have today for AP Human Geography, specifically Unit 1, that perception is, well, it's just dead wrong.
It really is.
The sources we're diving into frame this not as trivia, but as the science of the where, which I love. It feels less like rote memorization and more like, I don't know, investigating a crime scene.
Yeah. That's a really great way to put it, actually. This unit, which is called Thinking Geographically, is really about the detective work of the world. It asks the big questions, like why is this town located here and not, 10 miles down the road? Or why do wealthy populations cluster on this side of the river while industrial zones are all clustered on the other side?
All right.
And most importantly, how do those spatial patterns actually dictate the decisions we make every single day?
And the stakes for you listening, they seem pretty high. We aren't just talking about passing an exam, though, the notes do say this unit is about 8 to 10% of the AP test.
Yeah, it's the lightest unit by weight, technically.
Right, but we're talking about the vocabulary you need to actually understand migration, war, agriculture, global trade, all of it.
It is the absolute foundation. If you don't understand the concepts here, things like scale, projection, region, spatial distribution, you are essentially flying blind for the rest of the course.
Wow. Okay.
So our mission for this deep dive is to uncover how geographers actually think and how the maps and data they create quietly shape the decisions that societies make.
Perfect. And we've got a roadmap for this. We are slicing this into 3 parts. First, the tools.
Maps and the tech we use to make them.
Exactly. Second, the frameworks. So how we analyze space and regions to find patterns. And finally, Earth and society, that push and pull between humans and nature.
Let's start with the tools.
Yeah.
And I think we have to open with probably the most uncomfortable truth in the entire source material.
I love this part. It's the idea that every map you have ever seen is, to some degree, a complete lie.
It sounds so dramatic, right?
Okay.
Like some kind of conspiracy theory.
Totally.
But it's actually just math. Just think about it. The Earth is a sphere. Well, an oblate spheroid, technically.
Right. It's a 3D object.
Exactly. It's 3D. But a map is a piece of paper, or it's a screen on your phone. It's a 2D plane. You literally cannot take the skin of an orange and flatten it out perfectly on a table without tearing it, stretching it, or squashing it.
So when a cartographer, a map maker, sits down to draw the world, they have to make a choice. They have to break something.
They have to distort one of 4 things.
Yeah.
And those are shape, area, distance, or direction.
Yes, AD.
Right. You can keep 1 or 2 of those accurate, but you inevitably sacrifice the others. It is a mathematical impossibility to have them all perfect at the same time.
Okay, let's look at the famous examples from the notes. Because the map we all have in our heads, the one that's probably on the wall of every classroom you've ever been in, is the Mercator projection.
Oh, yeah. Created back in 1569. Now, the Mercator is brilliant for one very specific thing, and that's marine navigation.
Because of the direction.
Exactly.
Yeah.
If you draw a straight line from London to New York on a Mercator map, that line represents a constant compass bearing. So if you're a 16th century sailor just trying not to die in the middle of the Atlantic, you love this map.
You absolutely love it. But the trade-off is size.
Massive size distortion. As you get closer to the poles, things just get huge. Like on a Mercator map, Greenland looks roughly the same size as Africa.
Which is wild.
In reality, Africa is 14 times larger than Greenland. 14 times.
Which brings up a much deeper point that the articles mention. This isn't just some visual glitch. It shapes how we see power.
Yes.
Because if the Northern Hemisphere, Europe, North America, if they look massive and the global South looks tiny, that subtly reinforces a very Eurocentric worldview.
Precisely. Maps communicate hierarchy. They communicate priorities.
Right.
And that is exactly why you have something like the Peters projection.
Which looks totally bizarre.
It does. But it was designed specifically to fix that lie. It preserves area. So on a Peters map, Africa looks huge, South America looks huge, Politically, it's accurate regarding size,
But the trade-off there is,
the shapes.
right, they look like they've been stretched out like taffy.
It looks awful to most people. That's the trade-off. You get the right size, but you lose the recognizable shape of the continents, which is why most geographers today prefer the Robinson projection.
The Goldilocks map.
Essentially, yeah. It distorts everything a little bit. Shape, size, distance, direction. But nothing is terribly wrong. It's a compromised projection. Yeah. It just looks right to the human eye.
And then there's the good homolocene, which I think wins the award for the absolute strangest visual.
Oh, the orange peel one?
Yes.
Yeah.
It literally looks like someone took that orange peel and flattened it out, leaving these massive blank gaps in the ocean.
It's great for showing landmass accurately without distorting it too much, but it's terrible for navigation. I mean, you can't sail a ship across a white gap in the paper.
True. But the big takeaway here isn't just to make you memorize the names of these projections. It's to realize that whenever you see a map, any map, you need to ask yourself, what is this map maker trying to show me?
And what do they have to distort to show it?
Exactly. Now, those are all reference maps, right? They show us where things are. But the notes strongly distinguish those from thematic maps.
Reference maps are your GPS, your road atlas. They tell you how to get from point A to point B. But thematic maps, they tell a story. They use geographic data to visualize a specific topic.
Like the choropleth map. That's the one we see every single election night. Red states, blue states.
Yes, exactly. It uses color or shading to represent data. Darker usually means more of something, like higher population density or higher average income.
But then you have chordograms, and these are the trippy ones where the actual size of the country changes based on the data, not the physical landmass.
They are wild to look at.
I saw one of these in the notes for organic farming output. Australia looked absolutely massive because they have huge organic farming acreage, even though their actual population is pretty small. It completely warps your sense of the physical world.
It forces you to see the data world instead. It forces you to pay attention to the statistic. Then you have graduated symbols. Imagine a map where circles are placed over cities, and the bigger the circle, the more oil they produce, or the more traffic accidents occur.
Right. And finally, the dot distribution map. This one seems the most intuitive to me. One dot equals one thing.
It is simple, but it's incredibly powerful for spotting clusters. The classic example in every single human geography textbook is Jon Snow.
And, just to clarify, not the Game of Thrones character.
No, not the King of the North. We are talking about the 1850s physician in London.
Right.
There's a massive cholera outbreak, and at the time, people think it's just in the air, miasma.
That air, yeah.
So Snow plots every single death on a map of the city with a single dot. He doesn't look at a spreadsheet, he looks at the spatial distribution.
Know what happens?
He looks at the cluster of dots and realizes they're all centering around one very specific water pump on Broad Street.
So he shut down the pump. He literally took the handle off the pump and the outbreak stopped. That map saved lives.
That is spatial analysis in its purest form. He didn't just look at the list of deaths, he looked at the where.
Today, though, we aren't really just drawing dots by hand anymore. We've moved from individuals doing this to massive organizations collecting data.
We've come a very long way from, say, Ibn Battuta walking 75,000 miles across the Islamic world in the 14th century, writing down what he saw.
Which was qualitative data, right?
Yes. Descriptions, narratives, interviews, it's the how and the why. But today, we rely heavily on quantitative data, hard numbers, that how many.
And the biggest example in the U.S. being the census.
The census is the holy grail of geographic data in the U.S. every 10 years. And we really need to stress this for anyone listening. It is not just counting heads for fun.
The sources are very specific here. The census determines the 435 seats in the House of Representatives.
Yeah.
If your state's population drops relative to others, you lose political power. You lose federal funding.
It is a high-stakes headcount. But it's not just the government making decisions. Businesses live and die by this data. Think about a huge chain like Chick-fil-A. They don't just throw a dart at a map to figure out where to open a new location.
They're using GIS, Geographic Information Systems.
Right. Think of GIS as a smart sandwich. Or
Right.
a layer cake of data.
Okay, I like that.
You take a base map of a city. That's your bottom layer. Then you layer on a digital sheet showing average income. Then a layer showing daily traffic flow. Then maybe a layer showing where all your competitors are.
So you're stacking these maps on top of each other in a computer.
Exactly. And
Yeah.
you look through all those layers to find the one single spot where high traffic, high income, and low competition all align perfectly. That's where you build.
So GIS is layering data. And then we have remote sensing, which always sounds like a sci-fi term to me, but it's mostly just satellites.
It's gathering data from a distance, yeah. We can monitor deforestation in the Amazon without actually sending a guy with a clipboard into the jungle.
Right.
We can look at nighttime light emissions to compare the economic development of North Korea versus South Korea from space. It gives us this macro view that humans on the ground just simply cannot see.
Okay, so we have the tools, we have the maps, the satellites, the data, but a tool is basically useless if you don't know how to think with it. Which brings us to slice 2 of our deep dive, frameworks of spatial thinking.
This is the mental operating system of a geographer. And it really starts with two concepts that sound identical to most people, but they're totally different. Space and place.
Help me distinguish these, because in casual conversation, I definitely use them interchangeably.
Think of space as geometry. It's just the physical gap or interval between two objects. A classroom with empty desks before the school year starts is just space.
Okay.
But place is space that has been filled with meaning, culture, and values.
So when the students actually come in, put up their artwork, create inside jokes, and establish a culture in that room, that space becomes a place.
Exactly. Place has a sense of place. It has identity. When you feel homesick, you aren't missing a specific set of coordinates on a grid. You're missing a place.
And when we talk about where things are, we also have two ways of describing that. Absolute and relative.
Absolute location is the grid. Latitude and longitude, GPS coordinates.
It never changes.
Never. Your house has a very specific coordinate. But relative location is how we actually live our lives. If you order a pizza, the delivery app uses absolute location. But if I just ask you where you live, you don't give me your latitude and longitude.
No, I'd say I'm 10 minutes from downtown, right next to the big Target.
That is relative location. It's defined by time, connectivity, and landmarks. And this brings us to how things interact across that space. We have a rule in geography called distance decay.
Which honestly sounds like a law of physics.
It basically is. It says that the interaction between two places decreases as the distance between them increases. It's the friction of distance.
Okay.
You are much more likely to go to a grocery store that's 2 miles away than one that's 20 miles away. The connection decays over distance.
But isn't technology kind of killing that rule? I mean, we're recording this digitally right now. I can FaceTime someone in Tokyo instantly.
And that is exactly what geographers call time-space compression. Technology, like planes, the internet, massive container ships, it makes the world feel smaller.
Yeah.
It shrinks the relative distance.
Even though the absolute distance is exactly the same.
Right. So Tokyo feels closer to New York today than Philadelphia felt to New York in the year 1700. The time distance has completely collapsed.
That makes total sense. Now, there is one more concept in this framework that the sources say traps almost every single student on the exam. Scale.
Oh, the difference between map scale and scale of analysis, it's tricky.
Break it down for us.
So map scale is just the zoom level. Are you looking at a map of a single city, or are you looking at a map of the entire world? That's map scale.
Okay.
But scale of analysis is about how you actually group your data to tell a story. And the example from the notes about life expectancy is perfect for explaining this.
Let's walk through it, because this is fascinating. If I look at life expectancy data at a global scale.
The story is a really happy one. Humans are living longer than ever before. It's great news across the board.
But if I change my scale of analysis to a regional scale.
Now you start to see problems. North America is doing great, but sub-Saharan Africa is lagging behind. The story shifts from everyone is winning to some regions are winning more than others.
And if we zoom in even further to the national scale.
You see really stark contrasts. China, for instance, has a life expectancy of around 78 years, but right next door, their neighbor Myanmar is 13 years less. Same region. Totally different reality.
And you can go even deeper, right, to the local scale.
Oh, absolutely. You can find counties in the U.S. South that have lower life expectancies than some developing nations. The big takeaway here is that the truth changes depending on which scale you choose to look at.
So if a politician or a news article shows you a statistic, your first question should always be, at what scale?
Always.
Because it's not just about zooming in, it's about revealing completely different layers of truth.
Yes.
Speaking of grouping things, let's talk about regions. The notes call them constructs.
Right. Regions aren't strictly real in the sense that there's a glowing red line on the ground. We draw lines to organize the complexity of the world. And there are 3 types of regions you really need to know.
First up, formal regions.
Also called uniform regions. These are areas where everyone shares a common, measurable trait. It could be a language area, a climate zone, or a political entity, like the country of France.
Because the laws of France apply everywhere inside that border.
Exactly. Then we have functional regions.
And the notes say to think of these as a machine.
Right. They have a center, a node, and the region is defined by the reach of that node. So a pizza delivery zone is a perfect functional region. The shop is the node.
And the further out you go, the less connection there is.
Until you hit the absolute limit where they just won't deliver to you anymore.
Got it. So radio station signals, commuter zones for a big metropolitan area, those are functional.
Yes. And last one is perceptual, or vernacular regions.
These are the ones that only exist inside our heads. Like the South.
Exactly. Where does the South actually begin? Is Kentucky in the South? Is Florida in the South?
Depends entirely on who you ask.
Because it's based on cultural identity and perception, not a hard, measurable fact.
But even though we literally make these regions up, the borders, the transitional boundaries between them, they can cause very real, very physical conflict. The notes bring up Sudan as a major case study here.
It's a really tragic example of what happens when formal regions and functional regions clash.
Yeah.
So Sudan used to be one single country, one functional region governed from a node in Khartoum.
But culturally, the area was deeply split.
Deeply. You had the north, which was essentially a formal region of Arab Muslims, and you had the south, which was a formal region predominantly of Christians and animists.
And those two distinct cultural identities just couldn't coexist under the single government node.
They couldn't. It led to decades of horrific civil war, and eventually the map just broke. They split into two separate functional regions, Sudan and South Sudan. The political boundary literally had to move to match the cultural boundary.
It really just shows that lines on a map are totally temporary. They shift constantly as human geography shifts.
They really do.
Which leads us perfectly to our final slice today, Earth and society. We can't talk about human decision-making without talking about the actual stage we're standing on.
We can't act like we just float above the ground. This is human-environment interaction. And it starts with resources. Renewable versus non-renewable.
Which is a huge topic right now.
The shift from fossil fuels to wind and solar is probably one of the biggest geographic stories happening in our lifetimes.
And that ties directly into sustainability.
Right. The definition of sustainability is simple to say, but incredibly hard to execute. It's meeting the needs of the present without compromising the ability of future generations to meet their own needs. It's all about balance.
But the text makes a really big point here that humans aren't just passive victims of the environment. We don't just, find a cave and live in it. We modify the Earth.
We are terraformers. We terrace steep mountains in Asia just to grow rice where it really shouldn't grow. We irrigate deserts in California to grow water-intensive crops like almonds. And we build sprawling cities, the built environment.
I really like the comparison in the sources of Washington, D.C. versus Rio de Janeiro, because the architecture isn't random.
No, not at all. D.C. was built with wide avenues, neoclassical stone buildings, massive monuments. It was designed to project power, stability, and democracy. It reflects American values of the time.
Right.
But Rio is built entirely differently. It interacts with the coast and the steep mountains in a way that reflects Brazilian culture and history. Our cities are essentially mirrors of our cultural values.
But historically, geographers didn't always think humans had this much agency, did they? We really have to touch on the big theory shift in geography, from environmental determinism to possibilism.
This is a crucial concept for the exam. So back in the 19th and early 20th centuries, the dominant theory was environmental determinism. It essentially argued that the physical environment solely dictated your culture and your societal success.
This is that really old, harmful idea that if you live in a tropical climate, the heat makes you destined to be lazy, and if you live in a cold, harsh climate, you're forced to be smart and industrious.
Exactly, and we have to be extremely clear about this. The sources are clear, too. This was used as pseudoscientific justification for racism and imperialism.
Right.
It was a way to claim that Europe ruled the world simply because the European climate inherently made them a superior culture. It's complete junk science, and modern geography rejects it entirely.
So how do geographers view that relationship now?
We use a framework called possibilism. This theory says, yes, the environment sets certain limits. You cannot easily grow bananas outside in Alaska. However, humans have incredible agency. We have technology. We have choices.
So the environment gives us a menu of options, but we are the ones who choose what to order.
That's a great way to think of it. And with high technology, we can actually hack the menu. I mean, you can build a massive indoor ski slope inside a shopping mall in Dubai, right in the middle of a scorching desert. That is possibilism in action. We aren't just robots programmed by the weather. We make decisions.
So, looking back at all of this, the tools, the frameworks, the environment, what is the big synthesis here? Why does this unit matter to you listening if you aren't planning on becoming a professional cartographer?
The big takeaway is that geography gives you the toolkit to decode the news, to decode reality. When you hear about a border conflict or a pandemic spreading, or you see a new election map, you shouldn't just see shapes and colors anymore.
You should see specific human decisions.
Exactly. You are looking for the pattern.
Yeah.
You are asking, why is this happening specifically here? It moves you from just passively looking at the world to actively analyzing it.
You understand that the South is a construct. You understand that the world map on your wall is heavily distorted. You understand that data can be completely manipulated just by changing the scale of analysis.
It's honestly like putting on a pair of X-ray glasses.
Yeah.
It allows you to see the underlying structure beneath all the chaos of global events.
I really want to leave you, the listener, with one final provocative thought to chew on. We started this whole deep dive by saying every map is a lie because of physical projection.
Right.
But today, the maps we use the most, they aren't on paper, they are algorithms. Google Maps tells us the fastest route to take.
Yeah.
But that route mathematically determines which local businesses get foot traffic and which neighborhoods get completely bypassed and ignored.
That is a huge point.
So if a mapmaker holds the power to shape society, and the mapmaker today is now just unseen code, are we even aware of the distortions being fed to us every single time we open our phones? Are we navigating the real world or just the world the algorithm wants us to see?
That is a very dangerous and very important question to keep in mind.
Well, thanks for taking this deep dive with us. We'll see you next time for Unit 2.